Welcome to the first video in a series of videos for the TExES exam 4 to 8 mathematics. This is competency 1. In this competency, a teacher understands the structure of number systems. This competency is part of domain 1, which is 16% of your test. In this video, we will work with properties of real numbers. Before we begin, let's discuss the real number system. And if you aren't familiar with the real number system, I recommend that you go watch some videos and gain a little more comfort with working with them. One thing I do need to note is the natural numbers. We consider the numbers what we call counting numbers when we're working with our students at the secondary level. However, at the post-secondary level, there is a controversy about what constitutes a natural number. In some cases, the natural numbers must include 0, but for the purposes of our students and their testing, that is not a fact. In this case, when we include 0, we call it the whole numbers. And of course, then we have the integers, and then encompassing all three of those would be the rational numbers, which includes the following examples: integers, fractions, terminating decimals, non-terminating decimals with repeating patterns. And there are examples of all these things, all these numbers and values. Okay, and then we move on to the irrational numbers. Now, those are denoted in a couple of ways. There is some standard notation. In number theory, I've seen for the most part would be the R minus the Q. That's what the backslash indicates. That is subtracting out. Okay, that's what that notation means. And then they give some examples of what an irrational value would be. Make note of those before we move on. For these videos, I will use the TI-30XB multi-view calculator. Now that is presentation-wise the same as the TI-30XB and some of the other family of calculators. Actually, I do believe the only calculator that won't give you the similar functions in presentation would be the TI-34. That one will not be used in the videos. I may bounce back and forth from the TExES, XPro, and so forth. But I kind of like the look of the TI-30XB. Okay, let's look at number 1. The Venn diagram shows the relationship between the particular number sets. Okay, here is the basic diagram of how we look at the real numbers. The natural numbers is a subset of the whole numbers, and then the whole numbers are a subset of integers, and then the integers are a subset of the rational numbers, okay? And notice the irrational numbers are a subset on their own, and they're only a subset of the real numbers, okay? All right. Now, our question says, where should negative square root of 225 be placed on the Venn diagram? Well, what we need to do is pop that in the calculator and then see what that means with our rules, what constitutes each of these subsets. Okay, all right, so let's say push negative first. Negative, and then second, and then we need that square root, which is just above x to the second power. Okay, now we enter 225. Push enter. Notice that's an integer. How do I know it's an integer? It's an integer because, 1, it's negative, okay? And we know that that will not include, that can't be a natural number alone. It can't be in that subset. Well, it can't be in the subset of whole numbers because those two sets are very similar. Okay. Now it's negative and it is a whole number. So the next step up is integers. And we do know what integers are. Well, it's not a rational number in this form. What happened is they divided by 2. Well, that's not what square root means. So this violates a definition. And then integers are what we're saying it is. But irrational, well, that also violates a definition. Even if they make this mistake, it's, oh, look at that. I really honestly did not mean for that heart to go there. Probably shouldn't leave it. Technology. Okay, there we go. Okay. So in this situation, they're incorrect for a couple reasons. One, negative 112.5. That is terminating. It terminates at a half, meaning it stops. That violates the definition of irrational number. An irrational decimal goes on continuously, and we don't know where it stops. Okay, now let's look at D. D says it's a whole number. Well, this is an incorrect calculation, so that violates the calculation and it excludes this negative that was out in front of the square root of 225. So that is verified. B is our option. Number 2, which diagram best represents relationship among integers, rational numbers, and whole numbers? Now, if you remember what was discussed prior, whole numbers are a subset, meaning they're within our rational numbers, okay? So if we look at A and B, in A and B, they're showing, for example, A says whole numbers are not a subset of integers, and integers are not a subset of whole numbers. Well, either way, that's incorrect. We need whole numbers to be a subset of integers. So A does not meet that definition. Okay, B, same situation, and well, integers are a subset of rationals. They are not, say, equivalent to each other or separate. Disjoint is what we see here. That's not the case. And whole numbers, they're a subset of integers. Integers are not a subset of whole numbers. And again, rational numbers are not a subset of whole numbers. So B will be incorrect. Let's look at C. They have integers as a subset of rational numbers. Well, they are. However, you cannot say that rationals are a subset of whole numbers. That this simple fact right here is incorrect. So let's cross our fingers and hope D is correct. Let's see here. It is saying, D is saying, whole numbers are a subset of integers. I agree with that. And then it says, integers are a subset of rational numbers. I absolutely and totally agree. Okay, let's go to the next item. Now, as I go up, I need to mention something. Notice I didn't touch my calculator. This is just something that you're going to have to know. It's one of those things that in order to be able to manipulate correctly and understand what you're putting in your calculator, you do need to know those basic facts about the properties of the real numbers. Okay? All right, let's look at number 3. All right. Let A represent integers, okay, and set B rational numbers. Okay, that means they represent rational numbers. Which of the following diagrams shows the correct representation of set A and B? Okay. Well, first, we need to really analyze here. Well, if A represents integers, as we said in the prior question, that means A is a subset. Oops, if I can write. A would actually be a subset, and a proper subset, no less, of B. Okay, well, that being the case, let's take a look here. Well, option A, it does show A is a subset of B. Option B shows that. However, C and D show it the other way around. They show B being a subset of A. So I would say C and D are not an option. Now, A represents integers. Okay. So for this option A is -12, which is an integer. And B is supposed to be rational numbers. Well, I absolutely agree with that. I agree with that because all whole numbers can be written as a rational value. Okay, they are over 1, which is a rational. So I agree with A. B, I don't agree because, let's see. Oh, because of A. This is incorrect. This is not an integer. So B does not fit the definition of integers. Okay. All right, let's move on. Number 4, which of the following 10 numbers are irrational? So we need to understand what irrational means. Well, irrational is a number that it doesn't stop, meaning it the decimal itself continues forever. We see no stopping. It doesn't give us a repeating pattern. It just continues, and we honestly don't know where it ends. Okay, and our calculator can help us evaluate that. Well, first we look at 0. Obviously, 0 stops because it just does. It's 0. We could say the same about 10. We count from 0 to 10, it stops. So, yes, it's not even a decimal. So, count that out. Now, pi is a different story. Okay, that looks kind of sorry, I didn't mean to just mark all through everything. Okay, pi itself, let's evaluate it. And if you aren't familiar with the value of pi, let's take a look at our calculator. So what do we need to do? Well, this particular calculator and the family of TI-30s has a button. So you just push your button. But now you have to push enter. You have to tell the calculator, here's the value we want to look at. Okay, we're going to evaluate it by entering it in. Now the calculator has it and it's sitting waiting for us to do something. So what do we need to do? We have these little toggle buttons above the enter. Push that and it will automatically give us a decimal. That's how we go back and forth, okay? Let's take a look at this decimal. It does not repeat. And our calculator doesn't tell us formally, but we can see that it's not going to stop. And we see that we have so many place values. It stops because it has to. It kind of rounds for us because that's what the calculator does. The truth is, we don't even know where pi is. So we need to include that in our irrational list. Now that we have one irrational number, look at our options. C does not include it and D does not. And we're looking at all of them and looks like each choice has 3. So we need pi. Okay, now the next number is negative square root of 80. Well, let's clear out our calculator and look at that. Push negative. Second, square root is above x squared. So push the x squared. Put in 80. Press enter. And see, it gives us another square root, which is nice. However, we need to push the toggle. And now we see our decimal. And again, it doesn't have a repeating value. It doesn't stop, looks like, because we can count the places that we see in our calculator. So it is irrational. So we circle that. Now let's take another look. Well, they both have negative square root of 80. Okay. Now I can see option A. There's a Captain Obvious right here in option A. Let's keep going. Obviously, 11, even though it's a percentage, that doesn't matter. It's terminating. It stops. So mark that out. Now, here we have 2.5. Rational is defined as a repeating decimal. Well, 5 bar means that it's repeating. Okay. So let me show you something. Let's clear this out. Here's a little something that if you don't know, you need to know. Okay. Push the fraction button. I want you to push 5, put 5 in, and then arrow down, put it a 9, and push enter. Okay. And then your toggle. Look at what we have. That is a 5 repeating. Well, that's what's going on here. It would look like this. And always note that here on our calculator at the end, it wants to round up, but that's not the case. That is repeating. Any single digit number over 9 will be a repeating decimal. And that's what's going on here. And those are rational. So mark that out. And that means A is not an option. Well, that leaves us with B. Okay, but we're going to evaluate the rest of these numbers because it's something we need to do. So let's take a look at this next number. It has a pattern, but it has a forever repeating, increasing pattern. So it's not a stable repeat. It's like a pattern that changes. It's not a stable repeating pattern. So therefore, that is irrational. Now, let's take a look at 20 over 3. So again, I'm going to clear this out. Push your fraction button, pop in 20, arrow down, put in your 3, push enter. Remember, you have to do your toggle. That is a rational value because 6, that's repeating, and it's actually 2/3, to be honest with you. So that is 6 2/3. So that is a rational value. Now, negative 9.345, obviously that stops because it naturally stops. That is rational. So that would be on our list. Now let's look at the last value. Now, how would we put that last one in our calculator? Well, that's not a big deal because we can do that. We have something here. So push second. Actually, I'm going to push clear so you can see what I'm doing. We don't have as big a window as some of the other calculators. So kind of clear stuff out so you can see it. So let's go second and now go down to where it has our caret up right there. Okay. Oh, look at what it does to us. See that answer? It wants us to put in the 3 first. Okay, so let's clear that out again so you can see it. I want to see if I can get a 3. I'm going to push my 3 first and then second, caret up. See what it did? It popped it up for me. And now I'm going to put in my fraction. Remember, I use the fraction button. Then I put in a 1, go down and put in 27, push enter. And it's 1/3. 1/3, if we push the toggle button, we see that that is a 3 repeating. And by the way, just as our repeating 5, that is properly written also as 0.3 bar. Okay? All right, so that verifies that B is our option. I just wanted to go through each of those numbers so you could see it. And then also see, how do you put some of these values in the calculator? Okay? Now, that square root or the cubic or to the, fourth root or the fifth root or sixth root, that thing, every calculator is different. So you just have to get used to it. So what we had here, if we totally clear that out, I push second and then the caret up. And notice if I go over, it still wants to do that answer business. Don't do that. Whatever root you want. Let's say I want the fourth root. I push my 4, second, and then it's just a little easier to get that to work. Okay? All right, that being said, let's look at number 5. Okay, we've got the same thing going on, but we have fewer numbers. And for this option, they're asking, well, which of the following 6 are integers? Well, you need to know what an integer is. Or when you pop it in your calculator, you need to see the form of an integer. Okay? So let's look at -7. That's an integer. I'm going to clear out what we have in the calculator. -7 is an integer. So that is going to be an option. Let's change this. That is an option for us. So that is B and C. A, that's not going to work. And D obviously won't work. Well, let's keep going so we can prove that. Okay. Now, 0.8%, that's not an integer. That's a decimal. But let's put that in the calculator. Let me show you a little something about our calculator. It has a nice feature. So I'm going to put 0.8. Now, I'm going to label it a decimal. How do you do that? Well, we have that right above the open parentheses. So say second, open parentheses. Now see how it's perfectly labeled in our calculator. Push enter, automatically pops a decimal for us. So that verifies that's obviously not an integer. So we can mark that out. Now, the next value, that's 15/5. That's 3. Okay. And if you get tired and you don't see things right away, when you're testing, you get tired. So let's take 15, pop in the 3, push enter. We verified that's an integer because 5 is an integer. Remember, integers are the whole numbers, the negative numbers, the positive whole, the negative whole, plus 0. Okay. So that's part of our repertoire. Okay, well, that looks like option B. Okay, because we have our -7. We have our, oh, look at what I did. I put in the wrong thing. See what happens when you get tired? Either way, it still works. Let's see what I did. Okay, I'm going to put in 5. And now it's 3. I'm sorry, it's 3. But this is a good moment to watch what I did again to fix my mistake. I made the mistake. So I arrowed up and I arrowed up again. I highlighted what I needed to fix. I push enter. And now don't push enter again to put it back into your calculator. It's sitting there waiting for you to do something. We'll pop back over and change it. You can do whatever you want with it now. I could go up and change the top number, okay? Whatever I need to do, okay? I'm going to go down, put back the 5, push enter. Oh, I didn't put 5, I put 3, so I can fix it again. Highlight it, push enter, arrow backwards. See how I'm arrowing? I will put the 5 in correctly, push enter. It's 3. It is a whole number, so we're good. Now, let's look at 11/4. Okay, well, you can clear everything out. Actually, I'm going to clear out all the things I have here too. Clean slate. Okay, because we're putting in a lot of items. Okay, so let's push our fraction button, put in 11, arrow down. There's your 4. Push enter. Remember, all we did right now is we've entered it in the calculator, so our calculator can work with it. Okay, you have to tell it what you want it to work with. Now push our toggle button, and that is a decimal that terminates, okay? And that's obviously not an integer. Okay, so that's not in our list. Now, negative square root of 100, that's a negative 10. That's an integer. But if you're not sure, push negative, second, and then the square root, see which button I pushed, then enter your 100, push enter, that's negative 10. Negative 10 is an integer, so that should be in your list. Well, that is in the list of B. Okay, and notice that C includes a non-integer item, so that has to be excluded. So we verified that B is the correct option. And again, if we look at the last item, that's obviously a decimal and not an integer. Okay, this is the last question for this video. Uh, I hope you do look forward to us continuing and making more videos. And if you've watched our other videos for our other tests and the other items I've already posted, thank you so much for watching and liking, and especially if you've already subscribed. You are the best. And happy testing, everybody.